Welcome back, class. Today we're going to be going over lesson 2, which is evaluating exponents in a few special cases. If you have not taken yesterday's little formative assessment that was at the end of the unit, make sure that you do that before starting today's lesson. And if you don't have today's notes, print them off. Alright, today's learning objective is, given an exponent expression, the student will be able to evaluate the given expression. If you can recall yesterday, we were dealing with writing these exponential expressions in expanded form and word form. That's all we had to do. Today we are actually going to get to solve them. There are going to be some difficult problems today. You should have a calculator. If you don't have one, go get one or get one out now. Alright, let's start off by looking at the problem that we had yesterday. What we're going to be doing a lot of today is we're going to be expanding these out. So let's expand this problem out. And you should remember that three was our base number and 4 was our exponent. And the base just tells us how many times to, or what number to use, and the exponent tells us how many times. Okay? Now we are actually going to solve this, or evaluate. And how we do that is we can just do it piece by piece. So 3 times 3 is 9. Let's times it by another 3. 9 times 3 is 27. And 3 times 27 is 81. So 3 to the 4th power is 81. Let's take another look at another example. In example 2, this is 2 to the 6th power. So that tells us we have 2 6 times. So 1, 2, 3, 4, 5, 6. That's 2 to the 6th power. And we actually want to solve it today. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 2 times 32 would be 64. So, if you were told to evaluate 2 to the 6th power, your answer would be 64. That's why we can't be dealing with these or thinking that 2 to the 6th power is just 12. Let's flip our notes over and take a look at what we have. Okay? For these next two, just so you understand what we're doing or know how to solve these problems, I would like you to try the next two on your own. First, I want you to expand it out like we did yesterday. And then I would like you to actually evaluate the expression. So hit pause real quick on the video, try these two on your own. When you get them done, resume it and let's see if we got the correct answer. Alright, 4 to the 3rd power. I asked you to expand it out first, which means I have 4 3 times, and then I have to solve it. 4 times 4 is 16. 4 times 16 is 64. So 4 to the 3rd power is 64. Next problem might have taken you a little bit longer because if you guys haven't noticed yet, these problems get quite large, the answers, very quick. So 5 to the 3rd power means 5 3 times. So 5 times 5 is 25. 5 times 25 is 125. So 5 to the 3rd power, our answer we should have gotten is 125. Now, let us look at how to easily solve these using a calculator and why a calculator can be so important in this lesson. These first examples that I gave you were easy to solve in your head or on paper if you needed it. Some of these other ones that we'll see down below get a lot more difficult. Okay, so you should all have a calculator out in front of you, and I'm going to show you how to easily solve this using a calculator. So example 3 says 2 to the 8th power. You could, if you wanted to, write 2 times 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 2, 1, 2, 3, 4, 5, 6, 8 times, and then solve it out piece by piece. Or we're going to learn what some of these buttons on the calculator do. First, punch in your base number, which in this case was 2. And then if you look right below the pi symbol, it looks like an upward caret symbol. That raises that number to whatever power you want. In this case, we're going to go to the 8th power. So I did 2 up to the 8th power and equals 256. Let's go up to these two problems up above and just see if we get the same answers and have a little bit of practice with our calculator. So you punch in the base number, do that little upward caret right below the pi symbol, 5 raised to the 3rd power. And look at that, we get 125, 125. 4 to the 3rd power, let's clear it. 4 raised to the 3rd power, 64. Let's make sure we got the ones on the front right. 3 to the 4th power. 3 raised to the 4th is 81. 2 raised to the 6th power was 64. Just showing you that this is working for any of the ones that we've been dealing with exponents. So now, I just want you to take your calculator and solve these 6. Pause it real quick. When you're done, unpause it so you can see if you're using the correct calculations with your calculator. There are some special cases that I'm going to mention right after we get through these, so just go with your gut and trust these and see if you get the right answers. Alright, 3 to the 7th power. So I do 3, do the little upward caret button to the 7th. And we would get 2,187. Okay, something that I'm trying to make you guys realize is how large these numbers get, even when you're dealing with two small numbers like this. I did include in the instructions round to the nearest tenth. It's for problems like the next one. 1.8 raised to the 6. Get some 34.012224. You just have to go to the 10th power, which is that first number that we have. So the answer's 34.0. Some of you say, okay, well now we have a big number, but it's raised to the 0 power, so what's going to happen? If you got just one for that answer, you are correct. And I'll explain that in a second. 2 raised to the 14th. Another big number, 16,384. .5 raised to the 1st is just 0.5. And 0 raised to the 14th was 0. Some special cases that you're going to encounter is anything raised to the first power is itself. Okay, so I showed that in this problem right here. Because basically all that means is you just have one of them, so the number doesn't change at all. 0 raised to any power is 0. I showed that example here. If you have 0 and you just go 0 times 0 times 0 times 0 times 0, no matter how many times, you're always going to get 0. As you've learned in the past, anything times 0 is 0. And any number raised to the 0 power is 1. So I'm raising it to the 0 power, and it's 1. Anything. I could go 445 to the 0 power, it's going to be 1. I can go 78 to the 0 power, it's 1. So those are just some special cases that come along with exponents. Again, just like yesterday, to finish off today's lesson, before you start on lesson 3, I want you to complete the homework for this lesson, then check it with the answer key. If you have any questions, send me a personal message or write on the class blog. And if you still don't understand it or you want to, make sure you go back and check this micro lecture so you understand what's going on. And then when you're done with all that and you think you're prepared, go ahead and take the lesson quiz for today so I can make sure that you're understanding the topic we're covering. Thanks again.